What a lovely little roots of polynomials question to get us going in this paper. We're given a cubic, a couple of the coefficients. Remember, it's az cubed plus bz squared plus cz plus d in general. And here we're also given three roots, but they're all in terms of alpha. We're asked to basically find all the roots. So let's write down our formula. The sum of the roots is minus b over a in general. That is a formula to remember. In this case, it's going to be minus p over 1 or just minus p. That is going to come back in later on when we'll find out p. That's going to be an efficient way of doing it anyway. The sum of the pairs is then c over a, which is just going to be q. And the triple product in this case is no sum. It's going to be minus d over a. So minus 15 over a, or 15. And that is our way into this question, really, because we have the roots and we have the product. So let's figure it out. We can write down that alpha times 5 over alpha times alpha plus 5 over alpha minus 1 is equal to 15. And although this looks quite a complicated equation, these immediately cancel. And I can even divide through by 5 rather than expanding the bracket. So alpha plus 5 over alpha minus 1 is going to equal 3. And I'm then gonna, well, there's gonna be a couple of things I do. Okay, I'm first of all gonna minus 3, so I'll get a minus 4. And then this is a hidden quadratic in alpha. I'm gonna multiply through by alpha. Alpha squared minus 4 alpha plus 5 is 0. We've just got to solve this. You can stick it in your calculator, you can use the quadratic formula by hand, or you can just, I think, just completing the square is quite nice. Minus 4, that's going to give us a plus 1. This is then going to equal minus 1. Alpha minus 2 is going to equal plus or minus I. So we're going to get 2 plus I and 2 minus I as roots. Now, which one shall I set equal to alpha? Well, actually, if you times these two together, you will get 5. You'll be doing 4 squared plus minus I squared. So in fact, if you let alpha equal 2 plus I, then 5 over alpha would be 2 minus I. So it doesn't really matter which one you let equal which. And then when you add them, again, the order is not going to matter. So all we need to do now is add them. And then we'll get 4, just 4 actually, minus 1, we'll get 3. And those are our three roots. If you want me to be a little bit more comprehensive, then let's say that alpha is 2 plus alpha. Then 5 over alpha would equal 5 over 2 plus alpha. We would times by the conjugate. That then becomes 5 lots of 2 minus alpha. I'm not going to expand that bracket. On the bottom, we'd get 4 minus I squared. That becomes 5. You'd get a minus 2i and a plus 2i, get a difference of 2 squares. This cancels, and we get 2 minus I. And then adding them, 2 plus I plus 2 minus I minus 1. The i's cancel, and you can see where the 3 comes from. So I'm hoping you're convinced by that. Because we are basically there. So I've done that one. Hence, find the value of p. Remember what I said before? I said the sum is equal to minus p. So minus p is going to equal 2 plus I plus 2 minus I plus 3. We don't need to worry about q in this question, actually, but we could have calculated that if we wanted. And you also, you could work out the whole cubic, to be fair. You could multiply them together. There's all sorts you can do, but this is going to be the quickest way, so I strongly advise it. To cancel these out, minus p is going to equal 7, and therefore p is equal to minus 7. Lovely.